Good evening, sir.
Madam, good
Good
evening,
evening.
madam. Tell
Good
me,
evening.
Yeah,
madam.
yeah. So for in mathematics, Matlab is used for solving all kind of algebra, this numerical analysis and other kind of problem. Is it useful for financial mathematics in the
Yes,
field of?
yes, madam.
Okay.
Yes, madam. Finite element method also we
No,
use.
no, finite element method not, sir. In financial mathematics
Yes,
to
madam. Financial
find the,
method. Yes, madam.
yeah.
Same financial mathematics we use the finite element method also, madam.
Okay,
Yes,
okay.
madam.
Thank you, sir.
Okay, thank you, madam.
Yeah, very good evening to all the participants. We welcome you to the Matlab programming 7th day of the workshop uh, organized by New Research and Innovation Society. I welcome the speaker, Professor Bala Muralidharan, to continue for the 7th day. Sir.
Okay, thank you, sir. Thank you, sir. Okay, here all are accosted. Please post your attendance in the chat box. Please put it. Here some few members only posted in the chat box. Please put it to all. Okay, today is the last date. We know that actually very less, very one or just a few topics only we discussed. I think I know very well. Initially, I said this MATLAB was very big. Uh, it's all the domain. It's a backbone. MATLAB is the all the domain, all engineering field plus science field also. So it's a very big domain, you know that. Um, so this 7 days, 7 hours, it is not possible to learn. It's just intro only you have to learn, I think. But based on this intro, you will develop. You will develop through YouTube and MathWorks because this MATLAB full and full developed by MathWork. First class I said. Same thing I said you again. MathWork is developed by this whole MATLAB. So MathWork, everything is there. What are the tools are there? Everything is there. Just I show some tips. Then we will start. Yesterday, one one participant said, "Sir, please introduce some finite element method and finite difference method." Okay, okay, it's a MATLAB. Uh, is it visible? Hello?
Yes,
Yes,
sir.
sir. Visible, sir.
Yes, yes. Okay, okay. This one you have to see in upper term. Please see home. This is home plot. Here, lot of plotting tools are there. App. This is very all are very big domain. Here you will see first machine learning and deep learning is there. You will check it. Machine learning and deep learning. Second row. Third row. Each term, each logo, it takes 4 to 5 days or 4 to 7 days need because a very big tool. Initially, I said same. Next, math, statistics, and optimization. Here, 4 tools are there. You see, curve fitting, distribution filter, optimization, PDE modeler. PDE separate modeler is there. PDE separate modeler. Next, control system, design and analysis. Here, lot of things are there. Automotive, 4 tools. Signal processing and communication, so many tools. Image processing and computer vision, so many tools. Each tools minimum it takes 4 to 5 days or 7 to 8 days. Also not possible, I think. Test and measurement, computational finance. Ma'am, one madam said it's a computational finance.
Vijayalakshmi.
Vijayalakshmi madam. This is a
Yes, sir.
computational finance. This is a computational biology. This is a computational biology. Then code, general code generation also there. General code means R programming, Python, etc. Lot of R, Python. One more is there, Anaconda. Yeah, lot of things are there. All generated from here. Excel also. If you have any Excel, just upload, then generate to all those things. Then code generation, code verification, application, application development, database connectivity and reporting, simulation, graphics and reporting. So many tools are there here. Math tools also there here. This math, statistics and computation. Here this also very big tools. All are very very big tools. Matlab code are also there. In favorite you will see these all are already um, uh, in previously I used these all those things. Matlab coder, application compiler, sim biology like instrument control, these all curve fitting, optimization, these all. So interested regression analysis here is regression learner, neural network, everything is there. Machine learning is a very hot topic in 2023, not 2023, next year itself. Machine learning, deep learning, computational neural network, artificial intelligence, AI. Yeah, lot of so many things are there. So many very big hot topic are there. Here everyone developed by this Matlab. It's a very big application, Matlab. Okay. Okay. Now we will discuss. Um, okay, this one. Finite difference. Finite difference method. Finite difference method. Yesterday, one participant said, "Sir, please explain the finite difference method, sir." So, finite difference method is a very big topic actually. Finite difference and finite element both same, but these two are is a very big topic in numerical analysis. Numerical analysis. Matlab is also it helps more finite difference method, finite difference and finite analysis both. Even 7 days or 8 days minimum 7 to 10 days need for finite difference method and finite element method. So generally I just said and run for some 5 to 6 programs for today's session. First of all, this professor, actually this professor is very strong in the finite difference and element method. This professor name is Iter Bergara. Here this one link also there, www.ehu.es slash his name Iter. This professor has given lot of videos by using finite difference method in Matlab coding by using finite difference and finite element method. This professor has given a lot of notes and videos, everything given. This link also, this is a link. This is a link for this professor domain. The professor has given all the links, all the documents is given by for this link. 1 minute you see, just I run this part. Finite difference numerical methods of PDA in finance with Matlab. This is one of the course. From this course, everything this here, click here, this one. So you can find the notes. The notes is there. These all are videos. Ordinary differential equation, finite differential method to solve the second order partial differential equation, finite difference method to solve the black black Scholes equation. Here he used some textbook. He used some textbook. The one is a mathematical financial derivative, pricing and financial instrument, numerical solution of partial differential equations, finite difference method. This book, G.D. Smith. It's a very nice book. Third one is very nice book. Is a fourth one, finite difference schemes and partial differential equations. The last one, options, features, and other derivatives. Here, there's a third and fourth are very nice books. Okay. Here, this link also I will share. Yeah. Today, after completing the class, I will send all the material to our team members. Team members today compulsory will upload all the materials, all 7 days materials plus textbooks related to the textbook and tools and link everything we will upload in our Matlab workshop website. Please download it free. It is fully free. If possible, I will share it in our WhatsApp group also. Okay, just click the link. Just click this one, you will get the video, the full video, analytical solution of first order ODE, everything you got. Full video lecture also there. It is very useful for a finite difference and finite element method from differential equations, based on differential equations. Okay, first of all, I close it. I downloaded that material. This is a material. This material. Okay, first of all, I tell you ordinary differential equation. First of all, tell you what is the finite difference method and the finite element method. Generally, very big professors said both methods are same. First of all, the first one finite element method is a old method. Is a finite difference method. Both are same only. Both used by solving the differential equations. Differential equation means the two ways. One is ordinary differential equation, then another one is a partial differential equation. So solving differential equation in solving differential equation by using finite difference method or finite element method. So that is a main objective. Okay, the finite element method means in the physical shape. The physical shape is converted to simply said, simply good definition. Good definition in finite element method means the physical method. Physical method means it's an analytical method. It's an analytical method or physical problem is converted to numerical. The physical problem is converted to the numerical solution. Physical solution is converted to the numerical solution. That is a usage of finite element method and the finite difference method. Okay, the physical meaning means physical problem means both solved by ODE and PDE. Simply set the differential equations. Okay, from this differential equation, lot of real life application are there. Based on the real life application, we have to created one model. It's a mathematical modeling, some mathematical model. So we developed for some mathematical problems, mathematical modeling in real life. For example, one car, different shapes of cars. One car in a rectangle shape, one car in oval shape, one car in a square shape. There's a different type of shapes. That is physical problem. This is a physical problem. This physical problem, if you develop the equation means that is called as mathematical modeling. Such a mathematical modeling, you got one equation. You got one equation. That equation only one single scheme means, as a single parameter means, that is ordinary differential equation. More than one means is a partial differential equation. So you have to frame partial differential equation or ordinary differential equation or mixed, maybe mixed also. Otherwise, same partial is converted to ODE or PD. So the differential equation in the form of ODE and PD. Such type of problem in irregular form actually is a very irregular form, is a irregular boundary. Irregular boundary. Okay. Such type of irregular boundary, we got different equation. We got different equation. So different equation means different equation means we don't solve. We don't solve. We don't know the method for solving. So such type of equations we converted to numerical solution. So numerical solution, suppose the one scheme or one mathematical model converted to the numerical form means we need one scheme, we need one procedure. So that is a finite element or a finite difference method in different ways. Euler, um, um, Rang-Nicholson method, parabolic method, Bender schemate method. Lot of methods are there. Any one scheme, if you apply, the given procedure is converted to in the numerical scheme. So if you use the numerical scheme, easily we got one solution. We got one solution. This solution is an approximate solution one. That is error analysis also there. Each and every method we want to find a separate error analysis also there. So such terms we got one solution. So irregular shapes also we got one solution. For example, one car, making the car in different shape. So that is also one of the model. From the model you got one PDE equation. After the PDE equation, if you solve manually, is analytical or physically, it is not possible. If you use some transform, Fourier transform method or Laplace transform, any technique if you use, it is not possible to get the solution. So directly converted to numerical part. So numerically you got one solution. So our mathematical model validity, easily we will check the mathematical validity. Mathematical modeling is correct or not, easily we verified from the real life problem or real life data. That is a main background of finite element and finite finite element methods. Here now I have to solve some problems by using Matlab code. This material also I will share it, but here lot of coding are there. 5 to 6 programs I have to run it. Then what are the advantage? Everything I tell you. First, the analytical solution of first order ODE. So this is a first order ODE, general first order, this line I am teaching, this one. Okay, is a general first order ODE. General first order ODE, dy by dt is a first order ODE. Dy by dt equal to f of t comma y is a function of t comma y. Here the boundary y of t naught equal to y naught is a boundary value problem. Is that is also very big procedure. Boundary means a lot of boundary types of boundaries are there. It's a initial boundary problem and boundary value problem. Boundary value problem also lot of type. Based on the constant, it has lot of ways are there. Okay. It's a variable separable method. It's a simple first order ODE, variable separable method. dy by dt, this f of t comma y, this one, f of t comma y equal to g of t into h of y. G of t is a function of t, then another one is function of y. So the same thing, dy by dt equal to, in the cross multiplication, y variables in left hand side, t variables in right hand side. This is a boundary condition. It's a boundary condition. So integrate. Yeah, if we integrate with respect to y naught to y, then t naught to t, we got one solution. So that is a basics of first order ODE. Basic technical points, geometrical interpretation of the derivative. Okay, here y naught plus del y naught plus del y equal to y of, here this is y naught, y of x naught plus del x. So y naught equal to y of x naught. So this is a value alpha equal to the angle of elevation that is called as slope. This difference equal to x naught and x naught plus del x. What is the graphical representation, sir? Means it is very simple. One example I tell you. We want to prepare 5 centimeter sphere or 5 centimeter circle, anyone. So we have to give the order to 1 lakh ball you need. All ball size is 5 centimeter only. After you are getting all the balls, some balls it is not in 5 centimeter, because here lot of physical meaning are there. For example, 4.99 centimeter is one ball. One ball 5.001 is there. Here lot of differences are there. Is a error. So that is a small difference. This small difference is denoted as in del pi or del x or del in vertical and horizontal based on the difference. This is a differential equation definition actually. dy by dx at x equal to x naught means it's a difference y of x naught plus del x minus y of x naught by del x. It's a graphical representation. This graphical representation, one point is a tangent. It passes through the tangent at 2 points. Here one is first one is a initial point y of x naught. Second point, this straight line connected with 2 points. This is the first point. Second point, first point height del x, second point height del y. Distance equal to x naught. So x naught plus del x is a total distance of this one. First distance equal to s naught. Yeah, any graph, just the interpretation. One curve passes through one tangent, and the tangent passes through just 2 points. That's all. That is a difference. Here the values tends to 0. Limit delta x tends to 0. Delta x tends to 0 means y of x minus y of x naught minus y of x naught equal to 0. 0 by 0 is a indeterminate form. This indeterminate form is called as the derivative. Derivative means it's a rate of change of the displacement. It's moving on the one particular point to another particular point. It's a velocity. Okay. It's a Taylor expansion. This is a general formula for Taylor expansion. Here some lot of applications are given. Here the first second order 1 minus 1 plus x square, third order minus 1 plus x square minus x cube. The function Taylor expansion function e power minus 2x minus 2 e power minus x. This is a function. Based on this function, we got the Taylor expansion. It's a single order, very simple problem. Here the first order, second order, third order, fourth order is a final series up to fifth order. It is given. Just I will explain. Numerical solution of the first order ODE forward Euler method. First of all, I will give one this coding I will explain. This Euler method. This Euler method, forward Euler FE. This forward Euler method is the simplest and the most obvious numerical ODE integrator. It uses the slope at each point. At each point, easily we got the slope from this. Computed using the ODE, ordinary differential equation. To extrapolate and find the next point. So next point also easily identified. First point, what is the slope? Similarly, you have to get the next point also. And so the iteration also given. This Euler equation. yi plus 1, this box you will see. yi plus 1 equal to yi plus f of ti comma yi into delta t plus order of delta t square. The higher order fully 0. So we put it yi plus 1 equal to yi plus f of ti comma yi into delta t. This first two part only we put it. This is explicit method. Explicit, implicit, two method are there. First one single order ODE. The Matlab program integrate the first order ODE x dash of t equal to minus 2x of t plus t. The initial condition are given x of 0 equal to 1 using the forward Euler method. Using the forward Euler method. Okay, this forward Euler method I show you. I said the finite. This forward Euler method. Okay, student, is it visible? Hello, Matlab is visible? Hello.
Yes, sir.
Right.
Yes, sir. Yes.
Okay. First of all, I run this program. This program only. I copy paste the same this program. Just to copy paste. It is working. Just your copy. This is copy paste. That's all. Copy paste. Okay. The first program. Clear. Clear. The coefficients of equation. This is the equation ax dash plus bx plus ct. Here a, b, c are constant. Just put it a equal to 1, b equal to 2, c equal to 1. The initial values 0. Then another one is 0 to 5. 0 to 5 is the initial value. Number of times steps. Maximum 3000 given. Maximum 3000, 1000, 2000, 5000 may be given. Based on the solution, our solution is approximately nearest value means that is good. So this one put a maximum 3000 time steps are given. dt equal to, this is a differential equation, t maximum minus t initial value, the minimum, by maximum of t. The initial condition x of 1 equal to 1, the t of 1 equal to t of the initial value, t of t naught. That's all. This is a time loop. The time loop is the finite difference method. Time loop j equal to 1 colon maximum t semicolon is a for loop and end loop. We put it here. This j equal to j plus 1. Just to put j equal to j plus 1. That is a image to analyze the equation. This is a simple equation. Finite element method or finite difference method. This one you have to change it up to jth term converted to j plus 1th term. That is a difference. So x of j plus 1 equal to x of j plus dt bx of j c of j dt into divided by a. T of j plus 1 equal to t of the initial value plus j into dt. This is a for loop. After that, figure is a Euler method. X label equal to t, y label equal to x of t. Just run this program. Here done. Run command is the here editor, from editor. You don't confuse about it. Home plot app editor. From editor, run button is there. Run. Otherwise, simply you put F5 also, F5 keyboard. If you want, you can use it F5. Otherwise, run. Okay, just run this program. Yeah, this you got the Euler method. This is the solution. X equal to t. Then another one is x of t. The Euler solution. Okay. Here one circle you will see. This is a time loop. This time loop is the difference, finite difference. Here's a numerical solution to find the physical problem to physical. This is a physical problem. This is a physical problem. A x dash means a into dx by dt, a into dx by dt plus bx plus ct. It's a general term. Okay. Yes, then another midpoint problem I tell you next. Next one is a midpoint problem. Here this solving a x dash plus bx plus ct ODE by using the midpoint method. Midpoint method, this is a loop. This part is loop, time loop, initial condition. Initial condition you have to give same thing only. Same thing only. One the initial term of t2 equal to initial term of t, x1 equal to the given problem 1.0 minus dt into bx up to plus ch2 into dt divided by a. This is the initial condition. The same number of the time loops is also same 3000. Value is also same. A equal to 1, b equal to minus 2 is will increase the size will increase with the three constant value. Just to put it the three constant value, limit also 0 to 5 only. The maximum value, midpoint value is a midpoint method. It's a midpoint solution. It's a midpoint solution. This range also given by it's a 0.5. This 0.5 to 1. 0.5 to 1 meet in x-axis. Here the x-axis you will see. Just you will see the x-axis t 0.5 to 1, 0.25 to 1. This range you got the solution. These types of graphical representation easily you have to identify the new shapes. New shapes means one car is there, one instrument is there, but we want to change one mobile phone. Mobile phone, better you can take one mobile phone. Each and every mobile phone having different shapes. So the physical phenomena is different. Physical phenomena is entirely different. The car already I said. Yeah, one different shape you need. One different shape you need from the physical problem is. So you have to use some model, it's a mathematical model. From the mathematical model, you got one equation. Most of the equation in terms of differential equation. Differential equation means ODE or PDE mixed, or only PDE or only ODE. That such types of model you got. After the model, you don't get the solution. Physical exact solution, it is very difficult. Analytical solution is very difficult. Very difficult means we don't solve. Lot of methods are there. uh, for example, um, homotopy analysis method, various iteration method, modified iteration method. These all are analytical methods. Various iteration method, modified iteration method, homotopy perturbation method, homotopy analysis method, uh, Fourier transform method, Fourier lot of methods are there. These all are analytical method. These all method we don't get the these all method we don't get the exact solution. Very difficult. These all method we used to only power series technique. Power series techniques means each variable have to initial term to end term. In our convenient, it is calculated first two term only. Based on the first two term only, uh, drawing. Drawing mostly we used first term and second term. Third term very difficult. Analytical solution it is very difficult. So such types of problems. Most of the professors or most of the scientists used by only numerical part. Numerical part means if you change the physical phenomena per our convenient, your convenient you can change whatever it is. So you got a different equation, same different equation, Navier-Stokes equation, also lot of modification from Navier-Stokes equation. The high speed engine. Foreign countries also, you know that bullet train 500 kilometer 500 kilometer per 1 hour, 1 hour 500 kilometer, very high speed engine, also designed by Navier stroke equation only. It is a fluid dynamics. Navier stroke equation, you know that, I think. Here, lot of the parameters also there. That's also one of the PDE extension of the ODE. Continuity equation, dimension, Reynolds number, velocity profile. Lot of things are there. So such types of terms very difficult to find the analytical solution. So yeah, if you use the finite element method or finite difference method, easily to get the better solution within a second. Okay, the mostly I'm going to pause it. 1 minute. Okay. Okay. Is a midpoint. Is a RK method. This is also the RK method is also very powerful tool in numerical solution. Is that many of the members knows this part. RK method and Taylor series, both powerful. Okay. PD, I will explain some PD problems. Here is a PDA second order. Okay. The partial differential equations in the finite difference method. Okay, heat or diffusion equations. Heat or diffusion equations. Dou T x comma T by dou T. Capital T. Capital T. Dou of capital T by dou T with respect to x comma T. D means is a thermal conductivity. Is a diffusion coefficients. Dou squared T is a second order PD. Is a second order PDA. Some boundary conditions are given. These are boundary conditions. Initial condition, both are given. It's a boundary alley problem. Here the second order linear partial differential equation. This is a linear form. It is a linear form. Dou u by dou x, dou u by dou t. It's a division equation. It's a black skull. It's a division equation. This is a division equation of the integral form. I have to run some problems. 1 minute. This one I have to run it. 1 minute. I will explain for this problem. Is a step wave test for the lax method to solve the advection equation. Is advection equation for lax method. Lax method. Lax method. Is a lax method. This is a wave equation actually. This is a by used by the wave equation. Yeah, this is a wave equation, correct. Finite difference method, yes, is a wave equation only, right. It's a wave test, step wave test for the last method to solve the advanced method. It's a maximum length, minimum length, everything given. 1 minute, I will explain the coding. Okay, first the clear the parameters to define advection equation and the range of the space. Okay, the less method maximum 1, T also the maximum and the maximum length, maximum time, both 1. Advection velocity also 1, all 1 comma 1 comma 1. Okay, then the parameters needed to solve the equation within the last method. Number of time, first number of time steps 350 we put it. 350, suppose maybe 500 also some person used based on the solution and based on the real life model. Here some model is not fit. Some engineer said sir it is not fit, means you can change it. Time step you can change it. dt equal to t max by max t. The number of space steps 300. The wave front intermediate point u equal to 0. So here n integer is also 50. Then next one dx equal to L max by n. B equal to c dt into 2 times of b equal to c by 2. That's all. This one is the absolute value of b equal to less than 1 by 2. This is a initial value function. It's a initial value function. For loop and end loop. For and end loop. For if else otherwise end. Here I less than n times of this integer. I of 1 equal to 1, otherwise 0. So the into dx, x equal to I minus 1 times of dx. The boundary, the value of the aptitude at the boundary at any time. The boundary k equal to 1 to maximum t plus 1. So u of 1 equal to 1, n plus 1 equal to 0, time equal to k minus 1. This is a implementation. Implementation is this implementation. I comma k plus 1. I comma k plus 1. This is a this is you know that is a finite difference. So each term you put plus 1. That's all. Plus 1 or minus 1, left hand side or right hand side, based on the boundary. Suppose you need one boundary means just assign that is IA. You know the boundary. For example, x range it is in square box. For example, it is in square box. X range you set minus 1 to 1. Y range also you set minus 1 to 1. So you have to frame one square box or any boundary, any irregular boundary or irregular boundary. Suppose you need one point, you need one point, fixed point. Based on the fixed point, right hand side if you go, just put I plus 1. Left hand side I minus 1. Upper term j, j minus 1, j plus 1. So the sum of the 4 terms divided by 2, 4 is the average. That is the average. That is a fixation for row by column. That is a row. I means row, j means column. That is a assigning for irregular boundary. It is assigning for irregular boundary for the whole the areas. The some dotted points. Graphical representation. Graphical representation is a figure mesh to figure. Figure 1 mesh. Square wave is a square wave test plus method. Next figure 2. Figure 2 means is the amplitude of x. X label is amplitude. Y label is amplitude. Amplitude of x. Here this one equal to only y label is only t. Here first figure to find t only. Second one you have to find x only. This one I have to run this program. Just to copy paste advanced method here this advanced method clc run editor run. Yeah, you got 2 diagrams. So first diagram x axis, y axis is amplitude. Next one, this is a very beautiful diagram. We got square wave test within the less method. Okay, this less method, this is one of the irregular boundary. From this irregular boundary, you have to adjust it. X, Y is it is showing the value. You see, x equal to 0.2, y equal to 0.1, z equal to 0.9. Yeah, in real life application, I said car. We want to prepare one good shape car, but the same shape already everyone don't use it. For example, Benz, BMW, Benz car or BMW or Audi car. Any new shape you want means physical phenomena. Physical phenomena means inside. Inside you have to some changes. After the changes, we want to get some good model. After the model, its shape is irregular or irregular. But we need one unique model. So better solving the solution. You got one formula. After the formula, you are preparing one plate or number and one shape or theory. It is difficult. So such type of that situation we want to use a numerical solution. So the physical problem you said, sir, I need this way. Yeah, we want to prepare this model. Okay, based on the model we have to calculate it. We got it one um, unethical equation or unethical model. Otherwise, the mathematical model. You got one new mathematical model. The model solving that model, it is not possible. If you use any model, variable separate, you know that lot of models. If you use all the model, you don't get the solution. So such type of new mathematical model, new, underline the new mathematical model. If you use such types of technique, finite element or finite difference method, easily you got one solution. That is one of the approximate solution. Error analysis also it is possible. After the error, minimize the error, very less error. Initially I said we want to draw 5 centimeter, we want to prepare 5 centimeter ball, a sphere, 5 centimeter sphere need. But maybe 4.99 it is also possible. Your output you got some error. 4.9999 ball prepared. Your same machine. Machine means one model. You prepared one model. The model clearly showing 5 centimeter. So our output got 5 centimeter balls outside. Outside you got 5 centimeter balls. But if we check the testing, or if we check the testing of the same ball, some ball only it is showing 5, otherwise 5.001. 5.001 is also approximately equal to 5. 4.999 also you got. So that is a numerical solution and analytical solution. That is a small difference. Okay, the another program I explicit. I 1 minute here. 12 minutes are there. 3 programs. Krang Nicholson method is there. Implicit and explicit. 2 profiles are there. I will explain these 3. Okay. The first one explicit. I tell you the explicit. The parameters define the explicit program. I show you. 1 minute the explicit. Yeah, this is explicit model diffusion. Yeah, it's a heat diffusion. This is a heat diffusion. I enlarge them. Okay, heat diffusion is one dimensional wire within the explanation. A heat diffusion model. Here some parameters assigned: length of the wire, one, time also one. Parameters we used, number of times steps, 2500, 3000 may be used. N equal to 50, dt equal to t by maximum of a, number of space steps, dx equal to L by n, conductivity 1 by 4 quarter, stability parameter less than 1 means we know that we don't know n number of terms generated by less than 1. You know that the condition for 1 and 2. Um, in my lower, I once upon a time I studied in lower section. One maths professor asked, sir, how many numbers between 1 and 3? How many numbers lies between 1 and 3? Here lot of members said a lot of answer. But this Matlab program, lot of people are there, college professors and students are there. Anyone please tell me how many numbers are there lies between 1 and 3? Anyone?
Uncountable.
Huh?
Uncountable.
Yes, very good. It's uncountable because it's undefined. You know that is a continuous distribution. 1 and 2 also. Here many of the students said, sir, only one term is there, sir. 1 and 3. 1 and 2. Another question asked the same professor. Same. 1 and 2, how many how many terms, how many numbers lies between 1 and 2? 1 and 2 means one student said 0, sir, not 0. 1 and 2, how many numbers?
Infinitely many real numbers, sir.
Yes, yes, correct answer. Infinitely many real numbers. I actually everyone don't find out. Here infinite number of terms clearly said, ma'am. Real is also another big theory. 0.1, sir. How to say, sir, infinite? 1 to 2, he said 1.1, 1.2, 1.3, 1.001, 1.00001, 1.0002. We don't know actually. Actually, we don't know. The same professor said another one funny mathematics also. Here the stability parameter also said same thing. B less than 1. The same professor asked one more question. 2 plus 3 is less than 6. Is it correct or not? So all students said is correct, sir. Because 2 plus 3, you know that 2 plus 3 equal to 5. Same 2 plus 3 less than 6. Less than 6 means is correct. Because if 2 plus 3 equal to 5 is less than 6. Is the smallest number compared to 6. So everyone agreed. 2 plus 3 less than 6. Less than 6, everyone agreed. Yeah, it's correct, sir. Correct, sir. Correct, sir. All are said correct. Okay, 2 plus less than 6. Less than 6, all are agreed. Is correct or not? Okay. Next question, sir said, okay, 2 plus 3 equal to 4 is correct or not? 2 plus 3, 4 means all are said wrong. And just now, yeah, all are agreed less than 6. 4 also less than 6. 3 also less than 6. So all are, that is also correct actually. Logically correct, less than 6. But based on the iteration, based on the simulation, based on the numerical part, it is wrong. Because in our physical phenomena, we need 5. So you got 4. Your answer you got 4 is correct. You justified. Sir, all the formulas are correct, sir. All the coding are correct, sir. This is correct, but it is not correct. That is a analysis. Finite element method analysis. Finite element analysis. Analysis means we need 5. So we got 4.999 means it's correct. 5.00001 means it is correct. Agreed. Because in the physical phenomena, it is need 5 centimeter. You understood the concept. Based on the physical phenomena, you have to adjust that for this numerical solution. So if you find the exact solution means numerical solution is equal to exact solution means in future we want to use the same formula, same coding we will use it to all the problems. All the problems we will use it to the same concept. And that is the beauty of mathematics. Okay, it's a parametric parameters. Okay, I simply said the initial temperature, the temperature at the boundary. Initial temperature means first 0. Some people set 0. And then another temperature at the boundary. In the temperature, the heat transferred, how many centimeter transmitted by the conductor. Here engine rotated heavily. In aeroplane also used the same procedure, same equation model. Okay, the implementation of the explicit method. After that, we got two good diagrams. One a temperature diagram, then another temperature profile. One is a temperature profile in the explicit method. Another one is also the temperature. Temperature X, label X. Another one is the one is TA, temperature for T. Another one is temperature for temperature. Two profile we got. Just I run it this program 1 minute. I close the previous diagram. This explicit. This explicit diagram. This is explicit, very beautiful diagram. Okay, I show you in the full form. I show you. This is temperature within the explicit method. Based on the boundary, we will change it or adjustment. Suppose you just click this one, you got. Is it visible? Hello? X equal to 0.5, y equal to 0.0024. Is it visible?
Yes, sir.
Right. Okay. 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 Here change it because based on the boundary, we will change it. Okay. Next, this is a very good diagram. A lot of paper you have seen this diagram. Many of the fluid dynamics people, many of the application oriented people have seen this diagram. Four lines. It's a four profile. Is a very beautiful diagram. Manually, if you apply, manually, if you apply any analytical solution, any analytical method, you don't get such type of good diagram. Numerical part only you will get the beautiful diagram because it is possible to adjustment. All adjustment is there. Each adjustment is possible. It's a very beautiful diagram. This is a velocity profile actually. Okay, next implicit also.
Sir, can you describe the figure 2? How you can get that type of figure? Uh,
Second one.
yes, sir.
Okay. Explicit. 1 minute. This one you said.
Yes,
Second one.
yes, sir.
Temperature within the explicit method. This one you said. Okay. This is the same diagram. It's a 3D. Okay. This is mesh. Hello? Is it visible?
Yes, sir. Yes, sir.
Yeah, you see. This method, this is a mesh diagram. MESH in bracket x comma time comma u. Is it visible?
Yes, sir.
Yes. This is this one. Mesh. Same diagram is a mesh diagram. Mesh. Hello? Do you
So
understand?
mesh is a command.
Yes, command. Mesh.
Okay.
Uh,
Thank you, sir.
MESH.
Sir.
Mesh means the boundary. For example, uh, you have to frame one model. Okay.
Sir.
After the model, you are showing only frame only. Frame means just to show the model, but it is how to working we don't know. In how it is only for sketch. Sketch. You got the sketch. After the sketch, you build a house. If you show the house, everyone should understood the concept. You understand?
Yes, sir. Thank you, sir.
Before build the yes, thank you. Before build the house, first the engineer showing the sketch only. Sketch, everything is there. Everything is there. Length, breadth, height, each room, length, breadth, height, upstairs, everything. All bedroom, hall, kitchen, everything it is showing. But you don't know. The sketch you don't understand, but you just showing the lines only. After that, one figure is showing. That is beautiful house. So easy. If you show the full image, all are understood. That's all. So mesh means this wave. You got from this. The 1 minute. You'll see. This is the outline of the sketch. Do you understand? From sketch, you got mesh. This is a mesh. Do you understand?
Yes, sir.
Okay. Okay, next implicit also is showing. No time to today. No time. 1 minute. I run two things. Okay. Okay. This is also the another. This is implicit. Closed. Very beautiful diagram we got is implicit. This is a Krang-Nicholson. Krang-Nicholson. You know that here two forms are there in Krang-Nicholson. Parabolic, elliptic, both possible. The Krang-Nicholson method is a Krang-Nicholson method. It's a Krang-Nicholson method. Krang-Nicholson method, you will see. Hello, this diagram you will see. Yeah, it's a separately it is showing. Hello, you will see this sketch. You will see this profile. Yellow, green, this one.
sir.
Yeah, this is a Graham Nicholson. It's a parabolic wave, parabolic, parabolic, elliptic, and elliptic and hyperbolic. Three waves it is passing. Three types of bending. The bending and the point of inflection. This bending of the curve at three shapes possible. Parabola means you know that U shape. Elliptic means it's a oval. Hyperbolic means left hand side and right hand side. The oval for left hand side and oval for right hand side. So all types we used this Krang Nicholson. This is one of the PDE, partial differential equation model. Uh, some adjustment of physical phenomena. Based on the physical phenomena, these types of shapes involved means we will apply for this method. Okay, today I close it. All the materials I stopped sharing. Any doubt, please message me in WhatsApp. 1 minute, I close it. First of all, very thank to all the participants. Okay, right. Uncountable. Saurav Chaudhary said uncountable. Very good. Okay. Any general feedback, please tell me. Any general feedback, please tell me for general feedback from our 7 days workshop. Any other general doubt and help, please message me. Already you know that my number. Anyone participants, please give your some view about this workshop and some ideas. Anyone?
One.
Nivedita, sir. Yes, sir.
Good evening.
Good
Yes,
evening.
madam.
Good evening.
Yeah. Good evening, sir. First of all, I thank Newrains for arranging this workshop of MATLAB for 1 week. I thank the Dean and Sir, you also. Um, First of all, I can say that it is an interactive and informative session. You taught very well from the basic to many areas of mathematics. And whenever we asked any questions and all, you answered and you provided the link to further studies and all. Uh, it's very good, sir. And
Thank you.
you showed us where and all MATLAB is used, and I can say that you developed an interest within us to learn MATLAB. Okay. um,
Thank you, madam.
yeah. One thing only that we haven't received uh, any material in
Yes,
the
madam.
sense,
All
if you
today.
could have given some
Yes, madam.
homework
Today.
kind of thing.
Yes,
No,
madam. Today you will get all, madam.
yeah, during these 7 days now, if you could have given some homework and all, we could have tried, and if we had any problems and all, we could have interacted with you saying that where we got stuck and all. Otherwise it was very good session, sir. And within 7 days, you have shown many areas where we can use MATLAB.
Yes,
Thank
madam.
you, sir.
Thank you, madam. Thank you.
I thank Newrains for arranging this workshop.
Yes, madam.
Thank
Yes,
you, sir.
madam.
Okay. Thank
Okay.
you, sir.
Any other? Any other? Niveda Selvaraj. Niveda Sivaraj. Hello.
Chandrakanta Parida, say a few words.
Any other? Any other? Please say a few words. Because in this 1 hour we don't give lot of problems actually. Lot of
Sir,
problems. Yes.
they have given in the message all
Yes, sir.
feedback. They
Okay.
have they have very
Yes,
well
sir. Yes, sir.
appreciated the
Yes, sir.
workshop.
Ma'am said if you give some problems,
That's
is
good,
also
sir.
very help.
That's
Yes,
good.
sir.
That is really good, and
Yes,
that
sir.
is helping us to do in the future programs.
Yes, sir. This, sir,
Definitely, we
it's
will.
a, yes, sir. It's a very big domain.
Yeah,
So
yeah,
which one
yeah, yeah.
we will explain?
And
I
we
don't
can
know.
plan, sir. We can
Yes, sir.
plan in
Yes,
the
sir.
future programs.
Yes, sir.
Definitely, that's a very good suggestion.
Yes, sir. Yes,
We'll
sir.
take it, sir.
Thank you,
We'll
sir.
take
So
it.
thank you, madam.
Thank you, madam. Thank you.
Chandrakanta.
Yes, sir. Yes, sir.
Um,
Sir,
sir, tell me, sir. You say few words, sir.
sir, it's a very good experience of 7 days for me, and thanks a lot, sir. You
Thank
and
you.
the
Yes.
Newrains society.
Yesterday you said a very big topic.
Yes, sir.
Thank you, madam.
Actually, I am a PhD scholar of in the field of biofluid mechanics.
Oh, Bible, okay, good.
This method was very essential for that.
Yes, yes, I understood. I understood.
Yes, sir.
Very
Okay,
good.
thank
Thank
you.
you, Mr. Chandrakanta. Thank you.
Thank you, sir.
So, with
Any
yes
other?
inputs,
Okay. Any other suggestion? Please tell me. Positive or negative
Good
note. Or,
evening, sir.
so tell me, madam.
Sir, it was a very informative workshop, and we have learned some of the basics which we earlier didn't know. And I must say that you have taught so patiently and in a very good manner. Thank you so much, sir, and we look forward to more such sessions.
Okay, thank you, madam.
Sir, it will be really appreciable if you arrange a workshop on math quant as well.
Yes, madam. Yes, madam. I have seen, madam, already. Uh,
Yeah.
thank
yes,
you.
madam.
Thank you, madam. Thank
Thank
you.
you,
Thank you
madam.
so much, sir.
Thank you. So I think this is enough, sir. So many feedbacks they have given. You can
Yes, sir.
read
Yes.
it from the screen.
Yes, sir.
So
Yes,
I
sir.
thank all the participants for their interactive participation and very nice cooperation and joining the program workshop all the 7 days in time almost, except in one or two cases where they had due to some traffic jam or something like that, returning back to home was a little bit challenging for a few of the participants, but still they joined the workshop and they actively participated. I thank you all. I thank Professor Balamurudharan for his
Thank you, sir.
all his the huge effort he has taken to he tried to give everything in this workshop that I could see, and even I have learned so, though I am away from this programming, even I have learned something. I am really happy about it, and I enjoyed for all the 7 days. I have been watching what others view, what others questions, and all that. All these were really interesting, and many things I could see the participants could enjoy, and they were able to gain from the resource person. I thank you all. I am happy to inform all the participants that your mailbox has already received your participation certificates. Thank you all. Thank you very much, and good night. Thank you.
Okay. Okay.
Let's meet in the next program. Thank you all.
Okay. Okay, but thank you all. Thank you all. Thank you, sir. Thank you so much.
Thank you,
Balaji,
Professor.
Balaji, thank you so
Thank you,
much.
sir.
Thanks.
Balaji,
I thank Mr. Balaji for all
Balaji,
his contributions
Balaji,
in
and other,
successfully conducting this
yes,
workshop.
other team members also.
Yeah,
Balaji, you said others
the
also.
Tetron
Your
team
friends,
members have also worked
Tetron. Yes.
very well towards the success of this 7 days workshop. Thank you, Balaji, for your teamwork and everyone who has contributed for the success of this workshop. And I'm here to say that even participants away from India also took part in this workshop. A few participants from abroad have also joined our workshop, and I hope they have also enjoyed it. I welcome them also for all the future programs, including international conference, which is going to be held in the month of December, and all relevant workshops and conferences. Kindly you participate whenever you want to participate. We welcome you, and we are there to help you if you need anything. Thank you all once again, and good night.